Okay, so I'm going to go over some of the material that we looked at in the first part of the module, namely the subjects of numbers, polynomials, and vectors. And this is preparation for the first class test. I'll give some example questions, but I'm not going to run through the answers. I'm going to leave that for you to do. Okay, so the key points we looked at in the first part. We looked at the concept of number and the different types, the different classes of number. We looked at the notion of a polynomial, what form this takes, what attributes a typical polynomial has, and what the properties of polynomials are. We looked at quite basic models of a structure called a vector and at the operations that we perform on vectors. We looked at simple matrix structures, this idea of linear transformation and the way it's used in realizing computer graphics effects. So let's go back to what we saw with number. What you should be able to do, what you should be able to recall are the following. You should know the different classes of number, the different sets. So the difference between natural, whole, integer, rational, and the real numbers. You should be able to recognize which is the most appropriate to use in different applications contexts. You should be aware of the ideas that led to this notion of a real number, and also that particular subset of real numbers which are obtained as the roots of polynomial expressions. So typical example questions you might see are the following. You're given some application context, such as the first question there, which asks for the number of tenors who have recorded the role of Tristan in Wagner's opera Tristan und Isolde. You might be asked for the points total that a football team achieves at the end of a season, or the average mark obtained by a student, or the points the UK entry achieves in the Eurovision Song Contest, or the exact time it takes for a car to reach a particular speed. As I said, I'm going to leave you to work through those. Those have been set as a preparation test on Canvas rather than run through the answers in this lecture here. So I just want to give you an example of the sorts of questions you should be prepared to see. What about polynomial forms? What did we see there? You need to be aware of what the formal definition of a polynomial having a particular degree is, and of a polynomial being a function of a variable. You need to know about the notions of coefficients and this idea of the set of polynomials of a particular degree whose coefficients are formed from a specific set of numbers. You should be aware of how to add two polynomials, how to carry out this operation of scalar multiplication, multiplying a polynomial by a constant value. You should be aware of the concepts of what the root of a polynomial is and the properties of roots. You do not need to know anything about root finding algorithms or methods for finding roots. You don't need to know how to multiply two polynomials, how to factor out terms from a polynomial, or how to divide two polynomials. Typical questions you might see: you might be asked for the coefficient of a given term after expanding some simple form. You may be given an example describing a setting which can be captured by a polynomial, and you're asked to describe exactly what form that polynomial takes. You might be asked for the degree of a polynomial after expanding a particular expression. What about vectors and matrices? You need to be aware of the form and the attributes of vectors, so notions such as direction, the size. You need to know about the properties of components, that these objects are ordered, that they may be formed from different number types. You need to know how to apply the basic vector operations of addition, scalar multiplication, finding the size of a vector. You need to know about the properties and the definition, the requirements that a collection of vectors has to satisfy in order to define a vector space. You need to know about simple matrices and operations on those. For example, the process of how to multiply a given matrix by a vector. And you need to be aware of the vector space notions of dimension, how linear combinations are formed, the idea of linear independence, and this notion of the basis of a vector space. You do not, well, at this stage at least, need to know about operations such as what's called the scalar, the dot product, and you certainly don't need to be aware of the formal definition of vector cross product. You need to know about, you do not at this stage need formally to know about ideas such as matrix determinant, this notion of singularity, and this notion of inverse of a matrix. You should be able to form the product of small matrices, so 2 by 2, 3 by 3 matrices. You do not, however, need to know the general form for larger matrices. Typical example questions you might see: you might be asked for the size of a given vector. You might be asked for computations involving vector operations. You might be asked whether a particular collection of vectors is linearly independent, and if it isn't, to show that one of the vectors can be described as a linear combination of the others. You need to be aware of this idea of linear transformation and how it's related to matrix vector products. You need to know what's required in order for a mapping on a vector space to define a linear transformation. You need to know the form of scaling matrices as are used in computer graphics, this idea of homogeneous coordinates, and the way in which matrix vector products are combined together to implement various different graphics effects. And also you need to know the consequences that arise because matrix multiplication is not a commutative operation. So typical example questions you might see in the case of matrix operations: You may be asked what the effect of applying a particular collection of matrices is to a point in space. So, for example, this collection of 4 matrices. You may be asked how a given sequence of operations could be realized as a matrix vector product. So in particular, what dimensions are needed in order to realize a given collection of operations. This might be in quite simple forms, or it might be rather more sophisticated operations. So that gives an overview of the sort of material, the sort of areas you should be looking to revise in preparations for the class test.